All right. So here's what the SAS theorem says. And just a little reminder, the SAS stands for side, angle, side. Yeah. So here's what it says. I'll draw a little picture to help you see it again. But so if two sides and an included angle, and we'll talk about what that means in just a little bit. Yeah. Okay, so it basically says that if two sides and an included angle are congruent to two sides and an included angle of two triangles, then we know the entire triangles are congruent. That's side, angle, side. Okay, so let's say we've got these two triangles and we want to prove that they are congruent using side, angle, side. So the type of information we would need here is we need two sides. So let's say we know those two match. And say we know those two match. Okay, so two sides from one triangle congruent to two sides on another one. And the included angle needs to match from one to the other. Okay, the included angle simply means the angle that is in between the two congruent sides you've already worked with. Okay, so in triangle ABC, where's the included angle? Angle A, or BAC. Same thing, you're fine. Angle A, where's the included angle in triangle DEF? It would be D, right? So if those included angles match as well, like that, hey, Aaron, can we wait till later to talk about that stuff? Thanks. So if you trace out the triangle, side, angle, side, side, angle, side, okay? Just think about tracing it with your finger, and you can literally say the name of the theorem right as you do that, okay? It's probably the easiest way to determine if you've got it or not, okay? So the first thing that I want to do with you guys with this is, if I just give you two triangles, can you tell me yes or no they are congruent using SAS? So let's try it once. Okay, so let's say we got those two. Where are we at in the alphabet here? G. All right, and let's say that's all the information you have about those two triangles. So can I match things up using side, angle, side here then? Well, there are some things that I can assume about the picture that are not labeled on there. Let me start with that, okay? So can somebody give me one other thing that we know that's not already labeled on there somewhere? Mark? Oh, this JH in the middle? Yeah. Yep. That's congruent to itself or whatever because they both share that. So, yep, that's definitely part of it. Anything else, Eamon? Right. Again, that has to be 90 degrees because it makes a straight line and the other one's 90. Okay. So that should be all the extra little pieces we can match up there. Can we use SAS? Yeah, we can, right? So this matches here. This middle one kind of like matches itself, and then we've got the angle here and the angle there. So we can go side, angle, side, matches side, angle, side. Okay? So yes, they are congruent. And if they are, then let's write a congruent statement for it. So let's say I want to go with the first triangle, GHJ. So keeping things corresponding the right way, how should I write the second one then so it matches right? IHJ. Yep. Good. Okay. Let's try another pair of these guys. Okay, so everything that's labeled congruent is congruent from one to the other. Can I use SAS on this one? Okay. I'm hearing a pretty good mix. So somebody that says no, explain why. Who's someone has a Hannah? Go ahead. What do you think? Mm-hmm. Right. So the angle on the second one would have to be, the congruent one to M would have to be P, right? Do you see how they don't technically match up the right way? Okay. Remember, to use SAS, side, angle, side. That angle has to be included, has to be in between the two congruent sides. In the first one it is. So we're already ready to go there, but then with this one over here, that congruent angle is not in the same relative spot, so it doesn't work anymore. Okay, even though you got two sides, an angle, they have to be in the same relative spots to make it work. Yeah. 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 If you knew ON was congruent to ML, absolutely, that would work too. But as it stands, we don't know that, so got to say no, and then they don't correspond the right way. So be careful. In your homework, you're going to do several of these. They go really fast, but don't fall into that trap, okay? That angle has to be in between the two sides. And if it's not, then you can't do it. So, okay. The next thing I want to do with you guys with this is actually working on some proofs, and we're going to transition over to your journals. Now, remember what I talked about on Monday or Tuesday, the fact that the proofs you're going to do with this stuff are going to be some of the easiest ones you ever do. They have the same basic flow every time, okay? So don't throw in the towel before you even begin on these, okay?
I like how you give it the one day out.
No, that's true. It's a PI for anybody that needs to go get it, but yeah. It's PI. And then if you would please turn to page 136 in your journal. Page 136. Should look something like that. Okay. So there are basically three different chunks to how these proofs go with these triangle things. Any kind of proof you're trying to prove two triangles congruent, you're first going to write down the given information, which is true of any proof. And then the second stage of it, so to speak, is going to be trying to show all of the little pieces that have to match up. And then the end is going to be using SAS to say, yes, the triangles are congruent. Okay? And it's that middle stage that can get a little bit tricky sometimes, but usually it's pretty straightforward for what you need to go grab to do that. So for this first one, let's just get it started by writing down our given information here. BD is perpendicular to AC, and AD is congruent to CD. Mine, no, they do not. Oh, really? Oh, if your pencil's too sharp, maybe, I don't know. Okay, so this particular problem is actually just like one that you guys just did, okay? When I asked that question, can you use SAS to prove the two triangles congruent? If you look in your notes, the very first pair of triangles that we did looked almost exactly like this. Okay, and basically all we're going to do now is we're going to explain why for each part that we do. So think about, in the two triangles here, what was that other additional amount of information that we had to put into the picture to help us? And that's what we're going to do next. So what else did we need to know? Yeah, Tim. Okay. So that'll make a good step 2. Okay. We have to state that BDC is a right angle. How do we know that BDC is a right angle? Take a look at the given information. What about the given tells us that BDC is a right angle? Somebody other than these two guys, because they're always answering my questions for me. Look at the given information. What possibly out of that? You got two choices. What out of those two could possibly tell you that BDC is a right angle? Yeah. Right. Yeah, when two lines are perpendicular, they make right angles, right? That's why. Okay. So, what do you suppose I'm going to write down as my reason then? It would be the definition of perpendicular. Because they're perpendicular, it makes right angles. So it's the definition of perpendicular. Okay. Now, I know BDC is a right angle, and you look at the picture, and it's like, all right, I got these two matching now, right? Which is what I want. I have to actually write that out, though, that this is congruent to that, though. Okay? So ADB, CDB. And why is ADB congruent to CDB? They are both what? They're both 90 degrees because they are both right angles. So definition of right angles. Yep. Okay. Do I have everything I need for SAS now? Almost. We need the other side, right? So what side do I need to use to match up with the two triangles? BD. Now, how do you suppose I'm going to write that as a step in my proof, though? BD is congruent to what? Itself. BD is congruent to BD. Basically what you're saying there is the BD that's in this triangle is congruent to the BD that's in that triangle. Okay? Now that's one of those properties that I talked about before. I said, well, these are kind of silly, but we still got to write them down. Well, here's actually a use for it. Okay? Anybody remember what this property is called when anything is congruent to itself? Reflexive. Whoever said that, that is correct. That's the reflexive property. Okay, so now we've got, if you go up to the triangle here now. Okay, so we've got side, angle, side, side, angle, side. We've got everything we need, right? Okay, so we can jump right to the end of the proof now. We've matched all the little pieces we got to match. So triangle ABD is congruent to triangle CBD. And what do you suppose is going to be my reason? SAS. And then if you want to, you can put the little QED on there too, like I always do. You don't have to. Okay, so I want to draw your attention to some stuff in here. Remember how I said we need to spend our time matching up all the little pieces? In the actual proof, in where you're writing all your words in here, you have to have those three little matches, the two sides and the angles. So I'm just going to go through and circle them just so you can see it. And if you want to do this with yours as kind of a double check, it's not a bad idea. So there's AD and CD. So there's the segments. There's one pair of segments that are congruent. Then we did the angles right here. And then we did the other side. Side, angle, side. It should be in there just like that. The two sides and the angle that you need to do the SAS right there. All right, this next one, even easier. I think you guys could probably do this on your own, but we'll do it together anyway. Okay, so in this one, we've got this picture, and there are some congruent pieces already labeled in there for you. Okay, and so they gave that as your given. Jn congruent to Mn, Nk congruent to Nl. So I'm just rewriting that, and that's the given. So the two triangles we're trying to prove congruent in this thing are the two smaller ones. This one and this one. We've already got most of what we need to do side, angle, side, except for the angle. Okay? So look at the picture. Think side, angle, side, side, angle, side. What do we still need? Like, where are those angles that we should be using that are congruent? Somebody other than these two guys again. MNL and JNK. Right? Side, angle, side, side, angle, side. Those are the included angles. So, there's our step number 2, that those two angles should be congruent. So JNK and MNL are congruent. We're still got to give a reason for that, though. So look at the picture. How do we know those two angles have to be congruent to one another? Because they're vertical, right. Those are vertical angles. Those are always congruent. You got two lines that cross. The angles on opposite sides of that are always congruent because they're vertical. So that would be definition of vertical angles. Okay, and so now we have two pairs of sides congruent. We have a pair of angles congruent. We've got everything we need, right? Ready for SAS. Let's do it. So triangle JNK congruent to triangle MNL using some SAS. Done. Okay, that one only took 3 steps. And again, if you go through that proof before you get to the last step, you should have 2 congruent segment statements, which we do. They were both given to you. And there's the angle one right there. We've got it all set up. Everything was covered that we needed to cover in there before we could jump to saying the triangles were congruent. Okay? That's the process. Write down what's given, get the rest of the pieces you need, make the triangles congruent, SAS. Done. Okay? So, yeah, the rest of the time, homework. Let you guys get started on that.